Okay, very good afternoon. We are going to continue the second order linear non-homogeneous differential equation with constant coefficients for the case number 6, where this is a second order non-homogeneous equations. A d2y dx2 plus b dy dx plus b dy dx plus cy equal to fx, where the fx is the 6 cases, which is a polynomial with the trigonometric function, the 6 cases. Sorry, we got the 6 cases is actually, exponential with the trigonometric function. The last one is the 7 cases is polynomial, exponential, and trigonometric functions in this one. Okay, as you know, the solution for the non-homogeneous equations, you have the yc plus yp. Yc is a general solution for the homogeneous equations. Yp, we solve the Yp using undetermined of coefficients, where we choose the Yp based on the form of fx. Okay, if fx now is the 6 cases, you got the c exponent kx multiplied with cos beta x or sin beta x. Okay, hence the Yp will have the same form also. Okay, we have exponent kx. Okay, but here, of course, the coefficient for cos beta x, p, sin beta x, we put it different, p and q. So if this one clash, if this term, this one clash with the yc, hence we need to increase the power of x, power r by x power 1, x power 2, and so on. Okay, for example, solve y double prime plus 2y prime plus 2y equal to exponent negative x sin x. Okay, first step, solve the solution of homogeneous equation y double prime plus 2y prime plus 2y equal to 0. Okay, to solve that homogeneous solution, first of all, we get the characteristic equations by letting the second derivative by, your second derivative will be equal to, second derivative equal to the m squared. First derivative is the m, y is 1 or m power 0. Okay, in this case, we couldn't factor it, hence you have to either solve it using quadratic formula or you may use a scientific calculator. Okay, first of all, I show you how if you use a quadratic formula, hence the m, you have the formula is negative b plus minus square root b squared minus 4 ac divided by 2a. Okay, where the ABC is the coefficient for the polynomial. So that's why b is 2, so negative 2 plus minus, so b squared will be 4. A is 1. Okay, A is 1, C is 2. Then divided by 2 times 1. And then we may get this one is negative 2 plus minus, so you got 4 minus 4 times 2 is 8, 4 minus 8 divided by 2, which is negative 2 plus minus 4 minus 8, which is negative 4, so divided by 2, which is negative 2 plus minus, you have the square root 4 times square root negative 1 divided by 2. Hence you get this is negative 2 plus minus square root 4, you got 2, square root negative 1, which is I, divided by 2. That's why you get negative 1 plus minus I. So this is using quadratic formula, or you may use your scientific calculator Okay, for this one, you go to this is the latest K model, Casio Classic or FX570. You may go to the equation K modes here, and you equal. Okay, you can solve the simultaneous equation up to 4 simultaneous equation, polynomial up to degree 4. So just number 2, we got this is second polynomial, degree 2, we choose type 2. Then you input the coefficients K for your quadratic equation, which is the value of ABC, where you put it into your quadratic formula just now. Okay, where the A is actually 1, B is actually 2, C is actually 2. Okay, so you directly get -1 plus I and the -1 minus I. So you may directly use your scientific calculator. You mean you are allowed to directly use a scientific calculator. Okay, so after you obtain your root of your m, remember this is what we call, this is the alpha. Okay, and then the beta is a coefficient for the I, which is 1. Mean alpha equal to -1, beta is 1. Hence the YC complementary function is actually you have E alpha x, and remember A cos beta x plus B sin beta x, where the alpha in this case is -1, so you have E negative x, okay, A cos. Okay, beta is coefficient for the I, so beta, we have, 1. Alpha -1, beta is 1. So that's why your solution for the YC is A cos x plus B sin x. So this is a YC. Okay, second step, finds your YP. Okay, we choose the YP based on the form of your fx. Fx is exponent -x sin x. Then based on this table, you should have if exponent kx, then exponent kx. So our fx exponent -x, hence the yp also exponent -x, multiply p cos beta x plus q sin beta x. That's why the yp is exponent -x because your fx is actually exponent -x sin x. Hence the yp will be exponent -x p cos beta x plus q sin beta x based on this table here. Exponent kx here, exponent kx, and then p cos beta x, q sin beta x. Okay. After that, we have to check whether this yp clash with the yc. So you notice exponent -x p cos beta x, actually they are clashing. Okay, that's why YC, the YP, you have to multiply it by X. So after you multiply by X, they are no longer clash. Okay, because here you have only, the YC only product of exponential and cos, but here you multiply by X, so you got 3 terms, no longer clash. So if no longer clash, then you differentiate it 1 time, 2 times, 1 time, 2 times, so that you can use it, you can plug in into your second order differential equation, and then you have to differentiate using product rule. So this is U, this is V. Remember, you differentiate your product rule when you ddx uv will be u v prime plus v u prime. So and here, in order to differentiate u, you need to use uv again. mean here. Okay, in order to differentiate this u, okay, or maybe I follow here first, uv prime. So I copy it down. U is a x exponent negative x. Now differentiate v, you get negative p sin x. Differentiate q sin x plus q cos x. Okay, and then now to different, and then you have, so you already u v prime plus v. V is a p cos x plus q sin x. Okay, differentiate this one. In order to differentiate this one, applies the product rule again, which is, okay, you have u, differentiate exponent negative x, which is your v, you got negative exponent negative x, okay, plus your v, which is exponent negative x, differentiate x, which is 1. Okay, so this is u, this is v prime, this is v, this is your u prime. In order to get your u prime, you need to product rule again. So where this is u, this is a v prime, this is v, u prime is 1. Okay, you may simplify it first before you differentiate it second time. Okay, I may collect the term for exponent negative x. Okay, collect the term for exponent negative x. So exponent negative x, I have here exponent negative x only. I don't want the x time exponent negative x. I just want exponent negative x. Mean will be here, this one. All this thing time exponent negative x. So I got p cos x plus q sin x. Okay, this is for exponent negative x. And then I'm going to collect, okay, the term x multiply exponent negative x. Okay, x multiply exponent negative x. Okay, I collect the cos first. Cos, I got q minus p. Yeah, q minus p. This one for cos x. Cos here, cos term q, and then this is x exponent negative time p, so negative p. Okay, and then for the sin x, x negative exponent x, for sin x is negative p. Then q here multiply negative, so it's negative q sin x. Okay, this is for the term x exponent negative x. And then now you need to differentiate it second time. Okay, differentiate it second time. Okay, again, when you differentiate it second time, here u, in order to differentiate u, you need the product rule again. This is the v. So you got here, okay, you want u v prime. So you copy down u first, which is x exponent negative x. This second derivative, this one, y p double prime. X, u, and then v prime. Differentiate cos, which is negative p. Differentiate cos is negative sin x. Okay, plus negative p, negative q. Differentiate sin is cos, positive cos x. Okay, this is u v prime. Then plus v, which is q minus p cos x plus negative p, negative q sin x. This is v, and then differentiate your u. Okay, in order to differentiate u, you need product rule again, which is u, or actually the result here, u, this is v prime plus v, u prime is 1. Okay, this is the second derivative. Okay, and you may simplify it. Okay, simplify your second derivative. in terms of like the y prime here, exponent negative x and x exponent negative x. Okay, so now I simplify it. The exponent negative x, okay, exponent negative x, then I arrange from cos first. Okay, this one is all the x exponent negative x. I just want this one, right? I want this term here. And this one time with this one. So my x exponent negative x is actually, I got am I differentiate or missing? Let me check. Y double prime, you got already cause too messy. Okay, let check back. Let us check back whether this is this line is a YP. Okay, this is the U, this is a V prime, this is a V, this is U prime. Simplify it, you get, okay, this is the YP prime. So differentiate it second time. Okay, because this one hold on. Mean these two terms, we collect the x exponent negative x and x exponent negative x. Okay, you will know what happened because too messy. Okay, this two term is only for second term. I still have the first term here where I haven't differentiated. Okay. Okay, for y double prime just now, what I differentiate is only the second line here. So I need to differentiate the first line I left out just now because too messy. Okay, so now we, okay, this one for y p prime, we got two lines. What I did is only, okay, this two is for the second line. Now I need to differentiate first line. First line against, you have this is u, this is v. Okay, so for the first line, u exponent negative x, and then you differentiate this one. Differentiate p cos x is negative p sin x, okay, plus q cos x, okay, and then plus this. So this is u, this is v prime for first line, and then you got v u prime, which is actually v is a p cos x plus q sin x. Differentiate exponent negative x, you've got negative exponent negative x. Here, put here. Not too messy. Okay. And then the second line here, this is a u here. This is a v prime. And then v, okay, u prime. In order to get your u prime here, again, product rule. Okay, now I'm going to collecting the simplifies the y double prime. We got 1, 2, 3, 3 line. Okay, I'm going to, okay, this one, collecting the exponent negative x term. Exponent negative x term, first of all, I have here. And then, okay, you want exponent negative x term Here we got exponent negative x, here also exponent negative x. So for exponent negative x term, I will arrange, okay, in cos x and sin x first. Okay, cos x. So here I got here q cos x, p minus, because this one time here, minus p cos x. So minus p here, minus p, minus p, minus 2p, minus 2p, and then you got here q and q. So total you got 2 q minus p cos x. I mean, for the x exponent negative x, here you got q cos x, and then p cos x, and up with q cos x minus p cos x. So q and q, total 2q, minus p minus p minus 2p cos x. Okay, and then collecting the exponent negative x with sin x. So you got minus p, here minus p, this is minus q, then this one mean minus p minus p. So total I got minus 2 times of p plus q sin x. Here you got minus p minus 2p, and then okay, minus q minus 2q sin x. Okay, later on add up with the term x exponent negative x. Okay, x exponent negative x totally from here, this line combined with this one. I mean, this one multiply this one. Okay, so x exponent negative x, q, you got, let's say we arrange cos first. So minus p, this one maybe you erase it. Now I'm collecting the term, multiply with x exponent negative x, and then put up the cos term first. So q minus, okay, this is q time negative, so minus q, so you have minus 2q, okay, minus p time negative, positive p with negative p cancel, so only negative 2q cos x, cos here, minus p multiply with negative, so positive p, okay, time with negative p, cancel out, no more. Okay, for the sin term, okay, you got minus q, this minus and minus positive q. So sin term, q cancel. Hold on. Very messy. You may expand everything, okay? For the sin term, okay, you notice this one. You got minus q, okay, this minus q time negative positive q. So q cancel. Okay, p here, positive p, this is plus positive p, so plus 2p sin x. So if you thought this one messy, you may expand everything and then you collect backs. Okay, now okay, substitute yp, y prime p, y double prime p into the ODE to determine the coefficient of p and q. So the y double prime that we obtain here, so where the y double prime p, I got exponent negative x, okay, 2 times the q minus p cos x minus 2 times p plus q sin x plus, okay, plus x exponent negative x negative 2q cos x plus 2p sin x. Okay, checks. 2q minus p cos x. 2q q minus p cos x minus 2p plus q. So this minus 2q plus 2p. Okay, so this is for y double prime. Okay, add up with 2 times of y prime. Okay, your y prime is here. This one, these two lines. So the y prime, you got 2 exponent negative x p cos x plus q sin x plus x exponent negative x q minus p cos x minus p plus q sin x. This one. Okay. 2y prime. So this one multiply 2 also. So exponent negative x. Yeah. This one times 2. P cos x q sin x. And then the x exponent negative x, this term multiply by 2. Q minus p cos x. Q minus p cos x minus p plus q. Okay, or minus, okay, minus p minus q sin x. Okay, add up with 2 times of y, where the y is actually, the y is x exponent negative x p cos x plus q sin x equal to the right hand side is exponent negative x sin x. Okay, and then you may simplify or you can directly comparing the term. Okay, let's say if I want directly right hand side, I got the x exponent negative x sin x. So I can straight away compare exponent negative x sin x left side, right side. Okay. I just want, so this is x exponent negative x, don't want. This is x exponent negative x, I don't want. This x exponent negative x, we don't want. So I just take, I want exponent negative x here time with sin. So is I got 2q. How about this one? Exponent negative x time with sin. So it's here. Negative 2p, negative 2q. I got. Should have negative 2p, negative 2q. This one. This term. Negative 2p, negative 2q sin x exponent negative x with this one. 2q. Okay, right side is 1. Mean we're comparing the exponent negative x sin x left side, right side. So this one cancel. So negative 2p equal to 1, p equal to negative half. Okay, later on I compare the exponent negative x cos x. Okay, mean is here. Maybe this term here. This is x exponent negative x. This one don't want, don't want. So will be here. So it's 2q minus p plus 2p. So only 2q lah. Mean if you see these two terms, 2q minus 2p plus 2p. So it's only 2q. Okay. You got actually 2q. Right side we don't have this term, so it's equal to 0. That's why q equal to 0. Okay. And so yp, remember we have yp is what? Just now our yp. The yp is x exponent negative x p cos x plus q sin x. So q is 0, P is P here, plug in negative half. So that's why the P, well, YP will be negative half x exponent negative x cos x. Hence, okay, the general solution, you have the YC plus your YP. Okay, where the YC we have, okay, or the YC actually exponent negative x, a cos x plus b sin x, okay, plus with the YP that you obtain here, which negative half x cos x. Cos x times exponent negative x, or collect everything together, a cos x plus b sin x minus half x cos x. Okay, so I repeat one more time. This is the 6 cases of undetermined of coefficient where the right hand side you have the exponential functions multiplied with cos beta x or sin beta x. So in this case, our YC, you got exponent negative x, a cos x plus b sin x, because your m is a negative 1 plus minus I, where the alpha is 1, alpha and negative 1, beta is 1. That's why E alpha is negative 1, beta is 1. And then the fx, because the fx is, okay, exponent negative x sin x, hence the yp also exponent negative x, p cos 1x plus q sin 1x. If you exchange coefficient for p and q, for cos and sin doesn't matter. And then when we check this one, p exponent negative x cos x clash with this term. Q exponent negative x sin x clash with here. That's why you need to multiply by x. And you need to differentiate 1 time, 2 time. Only now, the u, in order to differentiate u, you apply product rule again here. I mean, this one, this actually, this is u. This, the bracket here is a v prime. This is v u prime. In order to differentiate your u prime, you need to use product rule. Again, this is u, v prime, this is v, u prime is 1. Okay. And then what I did is actually I just collect exponent negative x term and x exponent negative x term. Okay, for to differentiate second times, okay, first line here, this is u, this is a v prime plus v u prime. Okay, second line again, in order to different second line you need to product rule again. So this is a second line, this is a result for u, this is v prime plus v. In order to differentiate u prime, product rule like this one. Okay, and then I collecting the exponent negative x and x exponent negative x, and I put it into cos x sin x first. Then plug in your y p, y prime p, y double prime p into your differential equation. And then, okay, normally you may expand everything. Okay, I'm lazy, I just comparing, because I just want to determine p and q. And right hand side, I got the exponent negative x sin x, so I will compare this term first. Okay, so for exponent, okay, this one we don't want to compare because this is, okay, I highlight with you. This one because you have what? Here, this one can, this term is all the x times x exponent negative x exponent negative x. Okay, so don't look at this one, or when you simplify you may get 0. Okay, I just concentrate on here, exponent negative x sin x. Okay, so sin x. Okay, you got here, this one sin x times exponent negative x. So this one sin x times exponent negative x. So the coefficient here, negative 2p, negative 2q, plus 2q. Don't forget here. 2 times here, 2q. So that's why your negative 2p is 1, p is negative half. Okay, later on, I compare here. Exponent negative x cos x. Here, exponent negative x cos x. This one, the coefficient 2q minus 2p plus 2p. That's why it's just left 2q. Okay, right hand side, we don't have this term. That's why equal to 0. That's why q is 0. So plug in back, the yp is x, exponent negative x, p cos x plus q sin x. P is negative half, q is 0. So you get your yp. So your general solution is yc plus yp. With this, thank you for your attention.